Hello, today we are going to learn a substitution rule in integration. This is a very important rule in integration. The reason for that is there is a big family of problems those require you to use substitution rule. If you don't know how to use the substitution rule, then you will not be able to solve those problems. So far, we learn general integration problems. Those do not require you to use the substitution rule. Now, in this section, we learn the substitution rule. The problems related to substitution rule is a little bit harder than regular integration problems. All right. So I split this class or this section into two subsections. In the first subsection, we learn substitution rule for indefinite integration. In the other section, we learn substitution rule for the definite integration. All right, so go forward. First, we write substitution rule for indefinite integration. All right, first of all, I'm going to give you a theorem. There are two theorems. One theorem is for the part substitution rule for indefinite integration, and the next theorem for substitution rule for definite integration. All right, so this is the first part. Theorem, the first theorem here. If u equals gx is differentiable and f is continuous, over AB, then integration f of g of x times g prime x dx equals integration f of u du. All right, so this is the theorem. Let me explain something here. I don't know whether you are familiar with these kind of functions. Here the function is like f of g of x. These are called composite functions. Is called a composite function. Composite function is a function which has another function inside. All right, it has a actually composite function is made of two functions. There's an inner function and there's also an outer function. All right, there's inner function, outer function. As an example, if you consider f of x equals sine 1 over x, somebody can consider this as a composite function. All right, this has one function inside another function. Somebody can write this as f of g of x, where g of x equals 1 over xn f equals, let me say f x equals sine x. Okay, there are two functions here. You have the outer function, which is sine, you could consider sine x. The inner function is 1 over x. Let me use a different variable here. I don't put x, I will put a different variable like f of uppercase x. All right, so this is the function. This is how the function works. There's a function inside another function. Here gx is the inner function and f of x is the outer function. All right. Good. So you know about composite functions now. Before going further ahead, I'm going to give you a small method here. The method here is the technique that you could use to solve these kind of problems. Actually, this method is not available in books. I made this method by myself. So this method works for many problems, but there are some problems this method does not work. All right, keep that in mind. Go to the method. This method explains how to solve these kind of problems. This has some steps. Let's work on step number 1. Step number 1. In step number 1, split the integrand into two functions. Sorry. Such that they satisfy give me a second. Step 2. Now go to step number 2. Step 2 explains identify a composite function f of g of x, that is the composite function, among two functions. Such that g prime x is the other function. Then step 3, try u equals g of x as the substitution. Alright, see these are the 3 steps. Alright, first step is split the integrand into 2 functions such that they satisfy step number 2. Step number 2 says identify a composite function f of g of x among the 2 functions. Among the 2 functions such that g prime of x is the other function. Alright. Try u equals g of x as the substitution. Alright, let's do one problem, then you can understand this very well. Example number 1. The problem here is integrate 2x times x square plus 5 to the power minus 4 dx. This is the given problem. Check whether you can use any known formulas for this. So you know a lot of integration formulas. Check whether you can use them right now. So what I see is I don't know any formula for this problem. This is a hard problem, so I never learn a formula for this. Because of that reason, I'm trying to use the substitution rule. All right. So now, first I have to check the integrand. Okay, you have to split the integrand into 2 functions. Okay, so what is the integrand here? This is the integrand. Integrand is whatever inside the integration symbol. Integrand is this, the part, the written part inside the integrand symbol, integration symbol. So this is the integrand. Okay, that is the integrand. All right, now you have to split this into 2 functions. All right, you can try in different ways of splitting it. What I would try is I split like this. But I split this into 2x and then I split this into x square plus 5. First I split and then check whether it works. Alright, so this is what I get. And then in the step 2, identify a composite function. You have to identify a composite function, alright, something like f of g of x. Alright, I'm sorry, I made a mistake. This should be here. I forgot to put minus 4, the power minus 4. Now I have to understand f of g of x. That means a function inside another function. Alright, so you could treat the composite function as x square plus 5 to the power minus 4. Okay, you could treat this as the composite function. Why you say like that? Because it's a function of a function. All right, it's a function of function. That means here, let me write a little bit more. Is the composite all right, now you have to find out the function inside, which is gx. Here outer function is this big X to the power minus 4. Okay, the big X to the power minus 4. That is the outer function. The inner function is the big X, which is x square plus 5. All right. Here g of x should be the inner function, which is x to the power 2 plus 5. All right, so that is g of x. The outer function is gx to the power 4. And f of g of x equals g of x to the power minus 4. All right, that's how the composite function works here. Since g of x equals x square plus 5, you can take that as your substitution. Okay, that is step number 3. Step number 3 says try u equals g of x as the substitution. All right, you have to use that as the substitution. Let me make small space here. Try that as the substitution. All right, so let's understand the steps. Splitting this one is step number 1. And this is step number 2. And this is the final step, step number 3. Or these are the 3 steps. And now you're going to try u equals x square plus 5. All right, so use that. Then you have to differentiate u first with respect to x. So you'll get 2x. All right, so then you have to solve this for dx. I will explain why. For now, just solve this for x. That means dx equals du over 2x. Now what I'm going to do, I'm going to modify the given problem. The given problem is 2x. Now this is the given problem, which is 2x times x square plus 5 to the power 4. So now I'm going to substitute. For that I write integration symbol, and then I just keep this 2x as it is. All right, I write that 2x here, and then this part I could use the substitution. For this part I can make the substitution. That one is u to the power minus 4, and then for this part, for dx, I can again substitute. First, I think I better write that statement again down here. So let me write that statement down here, which is 2x x to the power 2 plus 5 minus 4 dx. All right, so this equals 2x, and for that you write u to the power minus 4, and then for dx you write du over 2x. You can cancel this 2x with that 2x, and then you write integration u to the power minus 4 du. All right, now you see you have only one variable, which is u. Now you can check whether you know any formula for this. Do you know any formula for this? Yes, that is just the power rule for integration. Okay, I'm going to use the power rule for integration. If you can remember the power rule, it should be, let's say, du to the power n du. Once you use the power, I'm sorry, I'm talking about the integration. Let me go back. the integration, you're going to use the power rule for integration. If you use the power rule here, it should be u n plus 1 over n plus 1. Okay, you learned this early. And the power rule for integration. Here you write u minus 4 plus 1. Here n is like minus 4. Keep that in mind. This is n. Okay, it is minus 4 plus 1 over minus 4 plus 1. And then you have to put plus constant. Okay, this is indefinite integration, all right? So you know that. This is indefinite integration, you have to put that. This is indefinite integration. Thus, this constant is required. All right, so you simplify this further, then it will be u to the power minus 3 over minus 3 plus c. All right, you might feel this as the solution, but no, this is not the solution. The reason for that is u is not an original variable. U is not an original variable. So you have to give back the original variable, which is x. Okay, which is x. So you have to substitute back for u. You're going to substitute back for u. You write minus 1/3, and then for u, you write x square plus 5. To the power minus 3 plus constant. Okay, so this is the solution for this problem. All right. Okay, so let's move to the next problem. Example number 2. Well, example number 2 is like this. Integration 1 over x square cos square 1 over x dx. All right, let's try solving this problem. Again, here the first step is to find a composite function. You split the integrand into two functions such that satisfies the second step. Okay, the first step is to splitting. You have to split this. Okay, this is the integrand. So you split that into two functions. The first function is x 1 over x to the power 2. The other function is cos square 1 over x. Okay, these are the functions I use as my split. And then in the next step, you have to find a composite function. All right. I know this is a composite function. I see that. Cos square 1 over x. So the outer function is cos square. The inner function is 1 over x. All right. The outer function is cos square. The inner function is 1 over x. All right. So I take f of g of x as cos square 1 over x is the the composite function. Okay, this is the composite function. The inner function g of x is 1 over x. All right, that is the inner function. The outer function, and f of g of x should be, if you write the outer function, it is actually cos square g of x. All right, cos square g of x. Gx is the inner function. That is step number 2. And now you have to use step number 3. Step number 3 says you have to treat gx as the substitution. Try gx as a substitution. Try u equals gx, which is 1 over x. Okay, so this is step number 1. And this is step number 2. This is step number 3. All right, now go forward. Now you know your substitution, which is 1 over x. Let me rewrite the given problem because that's convenient. 1 over x square cos square 1 over x dx. All right, now first of all, what I'm going to do is I'm going to differentiate u. Du over dx. I'm going to differentiate u with respect to x. So this can be written down as d over dx, x to the power minus 1. This is x to the power minus 1, you know that. 1 over x means x to the power minus 1. Here I use the power rule. If I use the power rule, it should be minus 1, x to the power minus 1 minus 1. If you can't remember the power rule for differentiation, it is like this. Let's say you have something like x to the power n d over dx. The derivative of that one should be n times x to the power n minus 1. All right. So this is actually minus 1 over x square. Right, now I do the cross multiplication and then I get dx. I solve it for dx. Solve it for dx. Then dx should be minus du times x square. I'm not sure whether you are clear about that. Let me show an additional step here. Here what I want to show you. Actually this is du over dx. Now you do the cross multiplication and solve for dx. If you solve it for dx, which is minus x square du. Okay, now I'm gonna substitute into this problem. All right. So let me get that down. It is convenient if I get that down. Now this equals, I'm going to substitute things. I just keep 1 over x square as it is, and then I write cos square, and then I check my u, which is, my u is 1 over x. Alright, for that I substitute u, and for dx, for this dx I can substitute minus x square times du. Alright, this part is gone for that part, and this part is gone for that part. The previous part also, let me mark them. This part is gone for that part, and for this part you substitute u. Alright, same thing here. And now I check whether I can cancel some terms. Here I have x square, and here I have x square, so I cancel them. Then I write, here it is minus, here it's minus, and here you have cos square, it is actually minus cos square u du. Okay, minus is a constant, you can get that out. You write cos square u du. All right. You had a very complicated problem early. You had a very complicated problem right here. I'm sorry, right here. Now you just simplified that problem into a simple one. All right. So the simple version of that problem is right here. All right. So let's go forward. Now let's check whether you have formulas for this. What you have to do is you have to integrate cos square u. All right. So I'm not sure whether you can remember a formula for this. Actually, you don't have any direct integration formulas for this, but you could use a trigonometric formula in this case, and then simplify this further. Then the simplified version can be solved by integration. All right. If you can remember this formula, let me write it here. For cos square u, there's a formula like cos square u equals 1 plus cos 2u over 2. You learn this in calc 1 when you learn trigonometry, when you use trigonometry, trig functions. All right. So I'm going to use that formula right here. So you substitute it directly. It is minus integration for cos square. You write 1 plus cos 2u over 2. Then du. You simplify this further. You divide. There are two functions. One function here, another function there. You divide each function by 2. Then you will get half. And then you write dx, and then minus, right, cos 2, u. I'm sorry, I made a mistake here. This should be u, and then this should be cos 2u. That. All right. Now you can get the constants out. Here minus half, and then you write du. Here half, and then you write cos 2u du. All right. Okay, so go forward, and here you write minus half. How to integrate that? It's very easy. That's the power rule for integration. Actually, what you have here is 1 to the power, x to the power 0. Here what you have is x to the power 0. All right, the power, if you can remember the power rule for integration, I already wrote this in above of this formula, above of this note. The power rule for integration, it is like this. If you need to integrate x to the power n, and the solution is x n plus 1 over n plus 1. You use that formula here. All right, so here x to the power 0, you have x to the power 0. Now what do? You write, I'm sorry, I made a small, not x, the variable is u, keep that in mind. Here the variable is u, all right. Now it is like u to the power 0 plus 1, because see, if you had n here, it should be n plus 1 there. If you had 0 here, it should be 0 plus 1. U to the power 0 plus 1, here 0 plus 1. And then you put minus half, and then integration of cos. Integration of cos is actually sine. You write sine 2u, and then you divide this by 2, because there's a formula for that. All right, and then you put this constant. Let me write that formula too. If you want to integrate, cos something like ku, k is a constant. If you want to integrate something like cos ku, the integrand of that one is sine ku over k. Okay, sine ku over k. Here k is a constant. All right, go forward. That formula used here. Here k equals 2. That constant is actually 2. All right. And then simplify this. If you simplify this, you will get minus half. Here u, here minus 1/4 sine 2u plus c. All right, so you might feel like this is the final solution. No, this is not the final solution. The reason for that is you have to substitute back the original variable. The original variable is x. So I'm going up and find the original variable. Where did I do that? See, the original variable should be u equals 1 over x. All right, go down here, I write for u, I write 1 over x. All right, again minus 1/4 sine 2 times 1 over x plus c. This is minus 1 over 2x minus sine 2 over x over 4 plus c. So this is the solution. All right. Let's work on the third problem. Example number 3. In example number 3, you have x square root 2x plus 1 dx. All right, now you have to go through those steps, those I gave you at the very beginning. These are the steps I gave you at the very beginning. All right, you have to use those steps. Step number 1 is to split this into two functions. I'm going to split this into two functions. First function is x. The other function is 2x plus 1, square root of that. And then you have to find a composite function. Okay, so this is a composite function. You can see it's a function inside another function. The outer function is the square root. The inner function is 2x plus 1. The composite function is f of g of x should be 2x plus 1 is the composite function. Composite function. All right. And the inner function, which is gx, should be 2x plus 1. And you could write f of g of x as square root of gx. Gx is the inner function. All right. Now the third step, you have to try u as the function gx, which is 2x plus 1. All right. That is gx. This is step 1. Give me a second. Sorry. I'm sorry. Give me a second. I made a problem here. What I want is I want to get this down. I don't need to change the color. All right. Okay, good. So this is step 1. This is step 2. And this is step 3. All right. There are 3 steps. You know the substitution. Now everything is easy. All right, go forward. You know u equals 2x plus 1, and then get the derivative of u with respect to x, which is 2, and then you solve this for dx. Dx equals du over 2. All right, and then I'm going to rewrite the given problem for convenience, which is x times the square root 2x plus 1. All right, now I'm going to make substitutions. I keep this x as it is because I can just work on that later. For this part, I type u. For this part, I type u. And for dx, I write, see, dx is du over 2. For dx, I write du over 2. All right, now I still have this x variable. Previously this such x was cancelled. If you go to the previous example, see, whatever you had here was cancelled with that thing. with that thing. And even in the previous example, in the very first example also, whatever you had here was cancelled with that. Now it doesn't happen. All right, let me work. Now it doesn't happen. This x is not cancelled with anything here. Because of that reason, you also have to substitute back for x. You also have to substitute something for x. That's easy. You can just substitute something for x if you work on this part. If you work on that, you can just solve that for x. Once you solve that for x, you can substitute that right here. All right. All right. And then let me do that right here. I know u equals 2x plus 1. Then I'm going to solve this for x. First, I just subtract 1 from both sides. So I get u minus 1 equals 2u and divide both sides by 2. So I get my x to be u minus 1 over 2. For that, I could substitute that thing. For this, I could substitute that. All right. Let me write down the next step. Then here for x, I'm going to write down u minus 1 over 2. This is square root of u du over 2. And then I'm going to simplify everything. 2 times 2 is 4, then it's 1 over 4. I get that out from the integral sign. Then here u minus 1 times the square root of u du. And here 1 over 4 integration. Then you can just expand this parenthesis. Here you have parenthesis, so you can expand that. For that you multiply this square root of u with that, and that is square root of u with minus 1. What you get here is u times, let me write this thing here. U times square root of u should be u times u to the power half. That means u to the power 3 over 2. All right. That's clear for you, right? U times the square root of u is u times u to the power half. Now you are just multiplying this with that. Instead of multiplying, you just add the powers. Okay, you add the powers. Here the power is 1, their power is half. 1 plus half is 3 over 2. So this is u to the power 3 over 2 minus u to the power half du. All right. And then you just distribute this integration sign. You know, there are two functions here. You can just split, or you can just distribute this integration sign into the first function and into the second function. That's what I'm going to do here. All right, I write this to be integration u to the power 3 over 2 du minus 1 over 4th integration u to the power half du. All right, now I'm going to use the power rule for integration. You know this power rule because I explained several times now in this section. It is actually u times u, and then here you have 3 over 2 plus 1. Here 3 over 2 plus 1. Here 1 over 4th. You have u to the power half. So it should be u to the power half plus 1, half plus 1 plus the constant. All right. So simplify this further. 1 over 4 u to the power, what is 3 over, let me simplify that in different color. If you simplify that, 3 over 2 plus 1 should be find the common denominator, which is 2. This is 5 over 2. Okay, u to the power 5 over 2. And here 5 over 2. Minus 1/4. What you have here is half plus 1, which is half plus 1 over 1. That means, sorry, you could put 2 over 2. Here that is 2 over 3. 3 over 2. Alright, so here you put u to the power 3 over 2, 3 over 2 plus c. Okay, now you have to simplify this further. Here you have 1/4, here you have 5 over 2. Okay, how do you simplify this? You could just flip 5 over 3. You can just flip 5 over 2 as 2 over 5 and then bring forward. Alright, so you write this to be 1/4 multiplied by 2 over 5 u to the power 5 over 2. Here same thing, 1 over 4 multiplied by 2 over 3 u to the power 3 over 2 plus c, and then you simplify. This is 4. You can cancel this 4 with that 2, here 2, and then you can cancel this 2 with that 4, is 2. So you have 1 over 10 u to the power 5 over 2 minus 1 over 3 u to the power 3 over 2 plus c. Alright, now you can find common denominator. Give me a second with the I made a small mistake here. Let me get this out, and actually this should be 2 times 3, which is 6. Okay, so this should be 1 over 6. Alright, now you can factorize this. Here it is 1 over 10. Here it is 1 over 6. This is u to the power 5 over 2. This is u to the power 3 over 2. So you can find a common factor. The common factor here is 1 over 10, 1 over 6. Among those two, you can take half as the common factor. Here 1 over 10, here 1 over 6. Half is a common factor. All right. Half is a common factor. Half. And here what will remain is 1 over 5. And from u to the power, here you have u to the power 5 over 2, u to the power 3 over 2. What is common among these two? Here u to the power 5 over 2, u to the power 3 over 2. What is common is u to the power 3 over 2. All right. You have learned these kind of factorizations in Calc 1. If you can't remember, please refer the note. It is the simple factorization. If you don't understand, spend a little more time so you can understand this clearly. Here it is u to the power 5 over 2, u to the power 3 over 2. What is common is u to the power 3 over 2. All right, let me write that. You write half times u to the power 3 over 2, and here you have 1 over 5. U will remain from there, and then here you have 1/3 plus c. So let me delete unnecessary parts. All right. And then you might feel this as the final solution. No, this is not the final solution. The reason for that is you have to substitute back for u. U is a new variable. U is not the original variable. So check back what should you substitute for u. Okay, so this was your u. So you have to substitute back 2x plus 1 for u. Okay, so you write this as half 2x plus 1 to the power 3 over 2, 1 over 5, 2x plus 1, and then 1 over 3. Alright, so this is a long problem. Spend little time to understand this problem. This is not a hard problem, but it's long. Alright, so let's move to the next part of the section. This is the first part of the section where we use substitution rule, for indefinite integration. Okay, substitution rule for indefinite integration. Now we learn the substitution rule for definite integration. That is the next point. Okay, go back. This is substitution rule for definite integration. All right. First of all, I will give you the theorem corresponding to this part. The theorem is somewhat similar to the previous theorem. First, I write the theorem. If G prime is continuous on the interval a comma b and f is continuous on the range of u equals g of x, then integration from a to b f of g of x times g prime x dx equals integration from, these are the bounds, the lower bound is g of a, the upper bound of g of b, and then you have f of u du. Alright, so this is, keep that in mind, this is indefinite integration, so you don't get the constant c. Okay, let me write that as a note. Note that this is, what I want to say is this is definite integration. This is definite integration. This is definite integration. So you don't get the constant c. right, so let's move to the example, directly to an example, so I can explain the theorem well by using the example. Example 4, you're going to integrate from -1 to 1 the function x squared x to the power 3 plus 1. All right, so this is the first problem. Here also you are working similar to the previous case. So can you remember we went through 3 steps? So you use the same 3 steps. First is split. You have to split this into 2 functions. The first function is x squared. The other function is x to the power 3 plus 1. All right, and then you have to this is with the square root set. Then you have to recognize a composite function. Of course, the composite function is this. Okay, this is the composite function. That is f of g of x equals x to the power 3 plus 1 is the composite function. All right, here g of x equals x to the power 3 plus 1 and f of g of x equals g of x square root. All right, so that is step number 2. Step number 3 is try u equals gx equals x to the power 3 plus 1. Okay, that's a substitution you would try here. All right, so let me mark the steps. Step number 1. This is step number 1. This is step number 2. And this is step number 3. All right, since you know u, now everything is so easy. Go forward and let me rewrite the given problem, which is integration -1 here, 1 there, x to the power 2, and inside the square root sign you have x to the power 3 plus 1, and here you have dx. Okay, you have to find dx here. You have to find dx. For that you have to differentiate u. Right, so let me include that step. Right, so u here is x to the power 3 plus 1. So you differentiate u with respect to x. That is 3x squared. All right, now you solve this for dx. Then you get du over 3x squared. That is dx. All right. Now you're going to substitute things here. that's a very special thing in indefinite integration. Here the limits, you have to work on these limits. This is the lower limit, that's the upper limit. That is easy actually. Here you have to substitute g of a. A is right here. Let me mark that here. Right, what I'm saying is here g of a, that means you are just substituting a for function g. Here is g of b, you are just substituting b for the function g. The function g is actually function u, right? So you see that here. G of x, u are same. G of x, u equals x to the power 3 plus 1. So here it is, the power is minus 1. In the new problem it should be g of 1, g of minus 1. Here the upper limit is minus 1, so this should be g of 1. Alright, then you write this to be x to the power 2, and here for this part we substitute u, because that is just u. Okay, then we substitute u for that part, and for dx we substitute that part, that is dx. So this should be du over 3x to the power 2. Alright, now you have to find g1 and g minus 1. Let me work that on here. G1 should be, just substitute 1 for x to the power 3. You know gx should be x to the power 3 plus 1. I'm sorry, what's going on? Yes. It is gone, right? Let me rewrite. What I'm saying is gx should be x to the power 3 plus 1. Because of that reason, g1 should be 1 to the power 3 plus 1, which is 2. G minus 1 should be minus 1 to the power 3 plus 1, which is 0. So this is 0 to 2. And here x to the power 2, and here u, here du 3x square. You can see this x square can be cancelled by that x square, and then problem will be simplified as an integration problem from 0 to 2 u du, and here 1 over 3. This is a very simple problem, right? So here the given problem is really complicated. Since you use the substitution rule correctly, it was reduced to a simple problem like that. Alright, you started a hard problem, very hard problem, and now the problem is like this. Now you are going to simplify that. This is a very easy problem, which is you have to use the power rule. It should be u 1 plus 1, 1 plus 1. Here the power is 1, u to the power 1. So you write u to the power 1 plus 1 or 1 plus 1. And then you have to put the limits from 0 to 2. Here 1 plus 1 is 2. 2 times 3 is 1 over 6. And u to the power 2. You have to put the limits from 0 to 2. Here 1 over 6, apply the upper limit, u to the power 2 to the power 2 minus 0. 2 to the power is 4, it is 4 over 6, which is 2 over 3. So that is the solution. All right. Give me a second. I made a small mistake here. The mistake is actually I forgot to include this square root sign here. See, you are just substituting u for that part. You are substituting u for that part, but you should not forget the square root sign. That square root sign here, that is over here, which is over here. And then I have to delete that. And then square root sign here means actually it is half. The power is half. U to the power half. So this will be half plus 1, half plus 1. Now this should be 3 over 2. And let me redo the problem from here. So this should be 1 over 3. U to the power 3 over 2. Here 3 over 2. 0 to 2. And then this can be written down as 1 over 3 times 2 over 3. And here it is 2 to the power 3 over 2 minus 0. And here this is 2 over 9. Then you have to simplify 2 to the power 3 over 2. Let's see how to simplify that. This is again calc 1. 2 to the power 3 over 2. This can be written down as, let me write this as 2 to the power 1 plus half, which is 2 times the square root of 2. Alright, so you write this to be 2 times the square root of 2. That means 2 times 2 is 4 times the square root of 2 over 9. So this is the solution. Alright, so let's move to the next example. I'm sorry, that actually this is, oh yeah, we have the next example. Go to the next example. Example number 5. Example number 5 is like this. Integration from 0 to 4 dx over x times ln x square. And here put dx. All right. Again, we have to go through those steps. We have to split this into two functions. First of all, let me rewrite this problem. I rewrite this problem like this. Integration from 2 to 4, and then I rewrite this as 1 over x times 1 over ln x to the power 2 dx. All right. So they are same. Top equals bottom. So now I'm going to split this into two functions. The first function that I get is 1 over x. The other function that I get is ln x square. All right. So there are two functions. Now I have to find the composite function. Of course, this is the composite function. I can take this as the composite. This is also a composite function, but this is the composite function that I would like. Because in this composite function, you can just get the inner function as 1 over you can get the inner function as just ln x. All right, so let me get this thing out. Now I write one over ln x square is the composite function. This is actually f of g of x. Here you take the inner function as just ln x, and your f of g of x equals 1 over g of x square. All right, and then you have to try a u as that, as we learned before. So this is your u. Try u equals g of x equals ln x. All right, and then you differentiate this. You know why we differentiate that. I will explain that later. So differentiation of u with respect to x is 1 over x, and then you simplify this for dx. So it will be x times du equals dx. All right, so let me mark the steps. This is step 1 of the method. The splitting part is step 1. This is step 2. And this is step 3. I'm sorry. This is step 2, and this is step 3. All right, go forward. So you found dx, and then you have to rewrite the given problem. The given problem is integration from 2 to 4 dx over x times ln x square all right. So this is the given problem. Now you're gonna substitute. Here it should be g of 2, g of 4, and here I write 1 over x, and here I write 1 over ln x square. You know ln x is u, so I write u square, and then for dx I write this part, which is x du. All right. Let me mark them. For that, I wrote this. For this, I wrote that. All right, and then you could see that this can be cancelled with that. And then for G2, G of 2, I just substitute 2 for this ln. See, this is G of x. All right, that's G of x. So what I need is G2. G2 is actually ln 2. And you also need G4. G4 is actually ln 4. That's because Gx is ln x, which is given right here. All right, now you write this to be ln 2 here, ln 4 here, 1 over u to the power 2 du. All right. And then go forward. Here 1 over u to the power 2. One over u to the power 2 can be written down as u to the power minus 2 du. Then a simple integration, right? You know the power rule. So it should be u to the power 2 plus minus 2 plus 1. Here minus 2 plus 1. Then you put the limits ln 2 here, ln 4 here. So this is same as u to the power minus 1 over minus 1 ln 2 ln 4. Okay, so this is same as minus 1. You write minus 1 and then here 1 over u. The limits are ln 2 ln 4. Now you're going to apply the limits minus 1 1 over ln 4 minus 1 over ln 2. All right, so that's what you get. All right, so you can further simplify this. You might feel like this is the final solution. No, because you can simplify this further, that you learn in Calc 1. Let me explain how to simplify this. ln 4 can be written down as, this is ln 4, it can also be written down as ln 2 to the power 2, because 4 is 2 to the power 2. And then you can get this power in front. So you can write 2 times ln 2. All right, for this part, for ln 4, you can write 2 times ln 2. With minus 1, 1 over 2 times ln 2. And here you have 1 over ln 2. Okay, now you can see ln 2 is a common factor. Here you have 1 over ln 2, 1 over ln 2. So what I'm doing is I'm taking ln 2 out. So here half minus 1. Half minus 1 is actually minus half. So here minus 1 ln 2, half minus 1 is minus half. Okay, if you multiply them, what you get is minus minus plus 1 over 2 times ln 2. So that is the solution. All right, so this is the end of the last problem. This section is little longer and this section has hard problems. You have your next homework available. Actually, I didn't give you hard problems for your homework, but I decided to do some problems in the in today's class notes. So that's why I explained some hard problems. Your homework is comparatively easy. This section is little hard, the substitution rule. The substitution rule has two parts. The first part is substitution rule for indefinite integration, and then the next part is substitution rule for definite integration. All right, so each part is followed by a theorem. Say this is the theorem here, and that is the theorem over there. Give me a second. That is the theorem over here. All right. We discussed three examples for first part and 2 problems for the second part. So this is good practice. All right. So that's all for today. Thank you very much.